Hello everyone, this is Vamsi Krishna. First of all, I would like to thank you all of you for watching this video. We are excited to share our presentation on machine learning and deep learning for natural language processing. Our goal is to explain how computers can understand and use human language with the help of machine learning and deep learning. Let's explore how this works and why it is so important in today's tech world. Coming to the introduction, let's start by talking about what NLP is and why it matters, what NLP stands for. As we know, NLP stands for Natural Language Processing, and it is a technology that allows computers to read, understand, and interact with the human language. You can think of it as a science behind the tools like voice assistants, translation apps, and even customer support chatbots. NLP helps businesses and people make sense of large amount of text data and communication more naturally with the machines. Today we will explore how NLP works and why it is so powerful with the help of deep learning and machine learning. Problem statement. One of the biggest challenges in NLP is teaching computers to understand languages like we do. Human language is so complicated with the words that have multiple meanings. Context matters a lot, and there is so much data to process manually. By analyzing all this data is too much time consuming. So we need NLP to make sure it should be done quickly, and NLP's main challenge is to close the gap between the human language communication and what machines learn can understand. Applications of NLP. NLP has many uses in everyday day-to-day life, everyone day-to-day life. I would like to explain some of them. First one is chatbot and virtual assistants. These will help answer questions, provide support, and support time for customer service teams. On sentiment analysis, computers use this to understand how customers feel about their products by looking at reviews or social media posts. Language translation apps like Google Translate make it easy to understand different languages, which helps the people a lot of time without no need to worry about the language. And next, speech recognition. They turns spoken language into text, helping with the task like voice typing. This help to save the time whenever we typing when typing is not good. It will help a lot of time. Text summarization. Uh, when we don't have to we don't have time to read a long summaries to gain the meaningful insights from the data, then we can use this text summarization to get the valuable insight about the data within the short span of time. Now let us dive into different traditional NLP approaches. Starting with the early NLP approach, it relied too strict on the rules set by the people to the computer, how to interpret the language. The system could handle certain process well, but struggled to handle the complex language. Coming to the statistical method, we will teach the computer based on the statistical data. This made NLP more flexible but still had limitations in handling full complexity of the language. And ending with the modern NLP, it combines both of these approaches so that it can overcome the disadvantage of other method. Okay, what is the role of machine learning in NLP? Machine learning plays a key part in NLP where computers can understand language through data, and machine learning is used for different types different types of applications like text classification, name entity recognition, and sentiment analysis. Starting with the text classification, sorting text into categories like labeling emails as spams or not spam. And coming to the name entity recognition, picking out names of people, places, and organizations in the large format of the text data is that what name entity recognition does. Coming to sentiment analysis, figuring out if the text expresses positive or negative feeling about the data. And machine learning lets the computer get better at the NLP task by learning from the example rather than relying on fixed rules. Deep learning is a type of machine learning language which has taken NLP to the next level. Deep learning, which is used to understand complex model, uh, not done with machine learning. Uh, there is a certain neural networks within the deep learning to train the data on different data and to validate the data. Here are the some of the neural networks or recurrent neural networks. This is used for understanding of sequence of words which is important in the language. And coming to next, long short term memory. It is an improvised version of recurrent neural networks which can understand data for long periods of time. And there is a transformers. It is a powerful model that can process all parts of sentence at once, making it great for translation and text generation. These DL models help NLP tools understand language in more natural way. The key challenges in NLP. NLP is getting better, but there are still some big challenges. Starting with the language ambiguity, words can have different meaning, and it is hard for computers to know which one is right without more context. And getting to the diverse languages and dialects, languages have different rules, and some languages don't have as much learn to data. And coming to the limited label data or data that is organized and explained is sometimes hard to find, especially for less common language. Sarcasm and context. Sarcasm, jokes, context, and the hidden meanings are especially hard for computers to pick up. So solving these issues would be a grateful great challenge for the NLP.
Hello everyone, I am Vinay and I'm going to continue with the slide 9, and it includes word, word embeddings, and in these word embeddings there are dense numerical representation of words in a multi-dimensional spaces. Each word is mapped to a vector that is captured its meaning in relation to other words, and it distributes the representations in this vector space. Similar words are located closer to each other, meaning that the embedding captures intimate relationships between words. That is like example, king and queen, and it would be closer to the king and the car. And the methods like vector to word to vec and glow are popular for creating these embeddings. They generate continuous value vectors that capture complex relationships between words, as opposed to traditional methods that uses sparse one-hot encoded vectors. Application and this application benefits are word embedding helps in NLP models to perform various tasks from effectively such as sentiment analysis. Uh, the sentiment analysis behind the words and phrases, language translation, and translating words and phrases by understanding the semantic relationships and the document classifications, and it is categorized the documents based on their content. This slide we can see transfer learning in NLP. Transfer learning in NLP, this approach is involving using pre-trained language models that have already learned generate language patterns and structures from vast databases. Pre-trained models like BERT, bidirectional encoder representations from transformers, and GPT-generative pre-trained transformers are examples of powerful language encoders. And these models are initially trained on large text corporate to understand language broadly, rather than for any specific tasks. Applications of NLP tasks after the pre-training, these models can be fine-tuned or adapted for particular tasks like question answering, text summarization, or semantic analysis. Fine-tuning involves training the model on a smaller task-specific dataset to make it excel in that particular area. Transformative impact: the use of transfer learning has greatly improved accuracy and efficiency in NLP tasks by leveraging the foundational knowledge gained from pre-training. This method has made it faster and easier to apply language models to a wide variety of language-related applications. In this slide, we can see the practical applications. Practical impact of natural language processing across various industries, especially highlighting how machine learning and deep learning are utilized to improve the process and outcomes. And in the healthcare, NLP applications are used to streamline process and improve patient care. For example, clinical documentations. NLP helps automated and improve the accuracy of clinical note and records. And the medical record analysis, analyzing the patient records to extract useful information for healthcare providers. And disease diagnosis, assisting in diagnosing the diseases by processing vast amount of medical data. And in the finance industry, NLP enhances security and customer insights. And in the sentiment analysis, understanding the customer sentiments can help in making better financial decisions. Fraud detection, NLP techniques assist in identifying the unusual pattern or language associated with fraud, improving risk assessment and customer protection. And in the customer services, NLP improves user interaction and operational efficiency in customer services. And the chatbots and visual assistants, these tools handle routine queries, improving response time and enhancing the user satisfaction. Operational efficiency: by automating responses and reducing the need for human intervention, companies achieve faster resolution times and high satisfaction levels. In this slide, we can see the futures of NLP. Multilingual NLP. Future NLP models will likely support multiple languages more effectively, helping to break down languages barriers and facilitate better global communication. This could allow businesses and organizations to expand their reach and serve a more diverse audience, making information accessible worldwide. Explainability in AI: as NLP becomes integrated into critical areas like healthcare, finance, and education, it's essentially to ensure that AI systems are transparent and accountable. And advancements in explainability will make it easier for users to understand how decisions are made by NLP models, which will improve trust in AI and support compliance with regularity standards. And the conversational AI, the text generators of conversational AI will focus on creating more natural and context-aware interactions. Virtual assistants, for example, will become better to understand the nuisance of human conversations, enabling more intuitions and effective interactions in various fields like healthcare, assisting the patients and healthcare providers by answering queries or tracking patient needs. Education, in education, supporting the personalized learning experiences by acting as tutors or facilitators in educational settings. And these customers in the customer services, improving the customer experiences by offering the real-time, adaptive, and helpful responses. In the ethical and privacy considerations, bias in training data, NLP models are often trained on large datasets that may contain biases reflective on society. If left unchecked, these biases can lead to discrimination or reinforce stereotypes in NLP applications. This is why it's essential to carefully curate datasets and develop techniques to mitigate biases in NLP algorithms to ensure fairness and equality. Privacy concerns, NLP techniques, essentially those handling the personal data raise privacy issues. This is a risk of misuse of or unauthorized access to sensitive information. So this makes it necessary to establish strong data protection measures, including data encryption, anonymization, and transparent practice that inform users about how their data is collected, stored, and used. And the responsible AI development building ethical NLP solutions required adhering to guidelines that prioritize the welfare of users and society. This includes the transparency and clear explaining how algorithms work and making the decision making process, understanding to users ethical guidelines, following best practices to ensure that NLP techniques are developed and user responsible, benefiting society while protecting individual rights. In this slide, we conclude that natural language processing has become a cornerstone technology in our data-centric era, allowing computers to process, analyze, and interact with human language seamlessly. Advances in machine learning, deep learning, and propel NLP forward, providing the powerful tools to tackle the inherent challenges of language understanding. And this development have led to transformative applications across numerous fields, enhancing patient care in healthcare, improving the risk assessment and security in finance, and boosting the customer satisfaction in service industries. As NLP continues to evolve, it promises to break language barriers, drive global connectivity, and unlock even greater potential for meaningful human computer interaction. And this is all about this uh, slide, and thank you.